Hello again, and in this video what we're going to do is take the graph of y equals tangent x and apply a series of transformations in order to get the graph of y equals 3 tangent 2x. Remember that the graph of y equals tangent x has a period of pi units. As you can see there, I have 2 points labeled 0, 0 and pi 0, and those signify the intercepts of each of the identical waves that tangent of x has. Okay, remember also that the graph of tangent has asymptotes at all of the odd multiples of pi over 2. So x equals negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, etc., etc. Okay, so also, since the tangent graph is an example of an unbounded graph, we do not have the concept of amplitude anymore. That was specific to sinusoids because they are bounded. We have sinusoids have a maximum value and a minimum value that the graphs evenly oscillate back and forth between. We don't have that with any of these other functions, the tangent, the cotangent, or the secant or the cosecant. So any number that gets multiplied to the trig function is simply going to be treated as a multiplier. There is no other real interpretation other than it stretches the graph, or it vertically compresses the graph, or it reflects the graph if that is the case, if the multiplier is negative. So in looking at that, let's just take these one step at a time. We have two transformations being applied to tangent x. We are making the angle 2x instead of x, which means it's going to have an effect on the period. So I'm going to change that first. So I'm going to change x to 2x, and notice that that indeed did shrink the period. We now have two waves in the place of one wave before. In other words, we have two waves on the interval 0 to pi instead of just one. And now applying the 3. So remember, the 3 is a stretch factor. So since the number is larger than 1, that is going to pull the graph vertically. So we should see a vertical stretch. And very much indeed, it did stretch. It stretches so much that it doesn't even look like an S anymore. It just kind of looks like a almost line linear, but not quite. I mean, not really linear, but just it lost its S shape. So those are the transformations applied to get to that graph. Now, of course, there's also vertical shifts and horizontal phase shifts. Those could be applied to the graph as well. So applying one by one, we can see how each one affects the shape of the graph.